Hi, I'm Marco, and I will guide you through the first programming exercise that you can find in my Java course on my website. Now we are going to open the window that will allow us to write the program using an online integrated development environment called CodeBoard. So please notice in the lower left corner the username. The first time you use the CodeBoard IDE, you won't see this, but my suggestion is to register to codeboard.io so that you can save in your exercises. Now let's describe the integrated development environment. This is made of different areas. The first one we are going to describe is the editor, where we will write our programs. Then we have the file tree, where we have our Java source files in the src folder. We have here two source files, bank account and main, both .java. And then the tests in the test folder. We have one test class in this case that can contain many tests. So the idea of one of these tests that are called unit tests is to exercise a particular method of our application to see how it behaves when we provide it with some input. On the bottom we have the output window, in which we will see messages that are output of the programs we write, or compilation errors or testing results. And we have the input area, in which we can insert input for our programs. Then we have the menus. An important menu is the project menu, in which there's the possibility to add or delete files and rename them. Another important menu item in this list is the save item, because it allows you to save all the changes to all the programs. Another important menu is the actions menu, for which there's a duplication in the buttons over here: compile, run, test, and submit. The compile button is, as the name goes, is used for the compilation of the program for syntax errors. Then the run is for the execution of the program. The test is to run the series of tests for the program that are the ones that are contained in the test directory. And finally, when we are happy with the tests that we have, we can submit our work, and the application will be tested with the tests written by the teacher. That probably will be a bit more complete than ours, and from them we will have a feedback in terms of percentage. For example, if we passed 100% of the tests, we are happy. Otherwise, we missed some important functionalities of the program, so we have to go back and check the source files again. So here on the left, in the file tree, we have different source files in the directory src. We have a bank account.java. We can see the content of this file by just clicking on it. And then the same for main here. The main Java file is the file containing this method here, public static void main string arguments, the starting point for any Java application. We will see it better later. So here in the main we have some instructions that we are going to explain now. This system.out.print line is basically used only for printing something that will appear here in the console when the program will be executed. And there's another here, and there's another here. The difference between them is that this is fixed. There's a fixed string here, and here the value of a variable is printed. The variable is my bank account, that is defined here, and attached to it there's an object of type bank account. We don't know exactly what an object is for now, but it suffices to say that it is something that can do something, and what it can do is specified in the body of the class. So for example, if we go into the body of the class here, bank account, we see that a bank account object, of which this is the definition, can return the value of the balance attribute here, and also we can deposit some quantity of money. So basically update the balance with the new quantity added. Back to the main, what we do with this instruction, my bank account.deposit, is exactly that. We are adding 10 to the existing value of the deposit variable, and then we print the result. Okay. Okay, let's try and solve the exercise now. First of all, we will compile the code to see if there are any syntax errors. Press compile. Compilation successful, so no syntax errors. Okay, then let's try and run the program to see if something weird happens. We have 3 strings printed, so the first one is corresponding to this instruction, and then this string here, the initial balance is, and then the value that comes out from the invocation of the method getBalance on the object myBankAccount. The object myBankAccount has been defined and created here, and then how do we know that we can invoke getBalance on myBankAccount? Because myBankAccount is of type bankAccount, which is a class that is the template from which this object is instantiated from. And then if we go to class bankAccount, we see that it has balance attribute and the getBalance method and the deposit method. So these are the things that we can use, especially getBalance and deposit, because they are public, so everybody can use them. So we go back to main, and we see that the program prints 0 as a result of an invocation of this method here, getBalance, and then 0 again because of the second print instruction. The current balance is, and this is maybe not what we expect, because between the two instructions there is a deposit instruction of 10, so we are depositing 10 on our bank account, and we are expecting that the balance then is 10 if at the beginning it was 0. But this is not the case, so we are not happy about it. We have to do something about it. Let's now run the test, clicking on test, and then you see we have failures. One test run and the test fails. Let's go and see what happens. So this is the Java class that contains all the tests for the bank account class. In this case there's only one test, so let's quickly see how the class is structured. We have the name, the class name here, then we have an attribute of type bank account because we want to use it to create an object and to exercise this object in various ways. This method here setup is used to do something before every test. Then we have the setup method here that will be invoked before every test will be executed. In this case we just create an object of type bank account and attach it to this reference my account here. So every time we run a test there will be a different object used. And let's see this test here. There's only one. We could have many. Every test is identifiable by the name and this @test annotation here on top. The name can be anything we want. In this case is test deposit 10 because we want to test that if we deposit 10 then there's 10 on the bank account afterwards. So we have a variable test input here that is 10, that is simulating what we are passing as an argument. And then there's the expected result that of course is 10. We invoke the method passing the test input, so 10, and we of course we have the actual result, that is what the application produces by invoking getBalance on my account. So we are expecting 10 in this case, and that's exactly what this instruction assert true states here, that the actual result is equal to the expected result, so 10 is equal to 10. The test fails, so this is clearly not true. From the stack trace here of the execution of the test execution, we can see that this doesn't matter. Okay, there's an assertion error. This is means this instruction failed on the test deposit 10 method, this one, okay, in class bank account test. Okay, so let's do something to fix the application. We go back to bank account, and of course the deposit doesn't work. Notice that here there are two placeholders. Insert code here is written in comments. We have to insert code here and here for this exercise. So first of all we have to implement some behavior for deposit. And what does deposit do, or what it should do? Should increment the value of balance by quantity. Okay, and this is what it is supposed to do. So we compile again. Fine. We run again just to see if it might work. No, it's exactly like before. Interesting. And the test, of course, should fail as well, but we try it anyway. And it's exactly like before. Okay, but now we understand that why maybe it fails, because even if the deposit is correct, it cannot show us that it's correct, because the get balance always returns 0. The get balance should return balance. And let's save everything just to be on the safe side, and then compile again. Okay, and then run again. Already from here we can see that something good is happening. The current balance after having deposited 10 is actually 10. And now we see if the test passes this time. And it passes. It's okay. Now the last thing that we can do is to try and submit the exercise so that the exercise will be tested with the teacher's tests that are possibly more numerous, and also maybe they cover some corner cases that we didn't think about. Fine, we pass 100% of all tests. It might be the case that we don't pass 100%, but maybe 80 or 60%, which means there are some tests we won't know which they are because they are hidden, at least some of them. But what we can do is go back to our test class and add tests here, think about the problem, think about what's missing, add new tests here in a way that it will pass all teachers' tests.